point source problems with coming from farmyards or from septic tanks or from wastewater treatment facilities, we do have quick fixes there. They might be costly, or there could be social or personal reasons why they're not being implemented, but they get fixed once, it's done, and it's done forever after.
It's great to be back with another Environment Edge podcast, and you're very welcome to the show.
Teagasc Agriculture Catchment Specialist Eddie Burgess joins us to discuss the challenges around water quality in Ireland currently and gives his outlook for the future in this area.
I'm Cathal Summers.
And I'm Deirdre Glenn.
Your Teagasc Sustainability Advisors, and we're back for another Environment Edge podcast, number 89, and here we go.
We're talking about standards for measuring water quality. So you have your drinking water standard, okay, within a catchment, but you've also got your ecological or your biological upper limit then for good water status, moderate status, high status. So can you just spell that out to us? You know, where is all that coming from? Like, one of them is 11 milligrams per litre, and then you have your nitrate level of 2.6 for ecological status, for high ecological status. Why is there such a variance between the two? And you know, we've seen improvements in different catchments over the years that we've been working in the ACP program, but is that bar too high, do you think?
Is that part? Deirdre, you're asking a loaded question there.
Well, it was something, I suppose, when I started my role as an ACP advisor, I looked at the drinking water standard, and then I looked at the level of nitrate standard for the ecology within the watercourse. And there's a big difference between the two.
Yeah.
You know, and I suppose, like, working in the Noena and different areas, we've seen a reduction in the amount of nitrate that's in the water bodies over in a proof of concept water body. There's been a drop in the nitrate level, but you know, it's a very low bar, isn't it?
Yeah, well, and it's not even the lowest. I suppose, first of all, before I answer that question, you're talking specifically about nitrogen. And again, I'm coming back to the fact that's only one aspect of water quality. Okay, there are many of them. And nitrate and nitrogen loss to water is very, very complex. And unfortunately, to add to that complexity, we have many different units being used to measure nitrate or nitrogen loss. We could measure nitrate, and the chemical symbol for nitrate is NO3, and the concentration of nitrate, you're weighing the nitrogen and the molecule of nitrogen and the 3 molecules of oxygen. And if you weigh nitrogen and oxygen, it weighs about 4.4 times heavier than just the nitrogen part. Okay. And the drinking water standard, you said the drinking water standard in the catchment. To be honest, I'd rather say the drinking water standard in a glass or in a tap. And if the nitrate in your water should be less than 50, and if it's above that, there has been recorded an association with a condition called blue baby syndrome, where the oxygen levels in baby's blood is lower than what it should be. I'm told that I had that. I don't remember.
Yeah.
I don't know if it has anything to do with nitrate or not. But anyway, it kind of rings a bell or resonates with me. I'm none the worse to wear for at this stage.
No, not at all.
But that's the drinking water standard, and it's measured in terms of nitrate. And nitrate is by far the biggest form that nitrogen takes when it's dissolved in water. But there are other forms of nitrate, of nitrogen. There's ammonia and nitrite and nitrate. And they're called, if you combine all those together, they're called dissolved inorganic nitrogen, DIN. But the amount of ammonia and nitrite are very, very small. So quite often we just talk about the nitrate and NO3N. And they're the figures you're talking about. And 50 milligrams of nitrate is the very same as 11.3 milligrams of nitrate N. That's the drinking water standard. But in salt water, where nitrate will give rise to eutrophication and have an impact on the ecology, there is a sliding scale on the concentration of nitrate that is going to have an impact, and that depends on how salty the water is. And if you have zero salinity, it's reasonably high, and if it goes up to maximum salinity out in the sea, it's a very, very low amount. And the sliding scale for the Water Framework Directive required status goes from 2.6 in zero salinity down to 0.25 in maximum salinity of N. Okay, now we don't have zero salinity seawater. It doesn't exist, but it's a sliding scale. So we measure the salinity and then we measure the nitrate to see, is this causing a problem? Now, because we don't have zero salinity seawater, the point that we generally tend to take is that the last non-tidal part of a river that is flowing into an estuary. And if every river flowing into an estuary at that point has an average concentration greater than 2.6, it's logical that you would expect the concentration in the estuary to be at or above 2.6. And if it is at that level, there will be problems in the ecology. So to answer your question, is it too low a concentration to have an impact in the estuary? No, it's not. However, in, for example, the River Slaney, and in any river catchment, we have many different landscape settings feeding into it. And I'm from Tullow, so I'll talk about the River Slaney. You go up to the Glen of Amal in the Wicklow Mountains, you have wet land, you have heavier soil type, you have heavier rain, so you have more dilution, you have more anaerobic conditions, and the nitrate concentration of the tributaries feeding into the Slaney from that setting are very low. You contrast that to very free draining soils around Ballin or at Ballycarney, where we have a catchment in Castledockrell, on Clonroach type soils. Through no fault of the farming practices that are doing there, because of the soil type, water percolates through the soil, it picks up nitrate, and the nitrate concentrations are going to be high. And when you mix them all up together, flowing across the weir in Enniscorthy, where it discharges into the estuary, you will have a dilution of, or combination of all of them, and we should be targeting for that point of the concentration to be below 2.6. But at small catchments in an agriculturally productive setting, I believe it will be very, very difficult for some of those settings to reach 2.6 in free draining soil types.
We obviously have challenges, and you've highlighted a number of them there now. But how, in your opinion, can we bring about improvements in water quality to meet, I suppose, the EPA reported water quality data? How do we get there?
I'm not trying to be awkward, and you can say thank you anyway, Eddie. But what aspect of water quality? And if it's for nitrogen entering into the estuary, which we've been discussing all along, there is no single silver bullet.
Yeah.
Whereas for point source problems with coming from farmyards or from septic tanks or from wastewater treatment facilities, we do have quick fixes there. They might be costly, or there could be social or personal reasons why they're not being implemented, but they get fixed once, it's done, and it's done forever after. So having sufficient storage, managing your yard right, not having rainwater running off a silage pit through a mucky area, storing farmyard manure and then flowing into a river, or fixing the wastewater treatment facility in Arklow, for example. When they're done, they're fixed, and they're fixed forever after. And we can do that, and do that quickly, and see results quickly in our rivers and also hopefully in our lakes. But to reduce nitrate getting into the groundwater, eventually feeding into the estuary, that's a long, slow burn, and there's no single silver bullet to do that. To reduce nitrate, we need to break one or both of two things. We need to, sorry, I'll come at that from a different way. For nitrate leaching to occur, two things have to happen. There has to be a surplus of nitrate above crop requirement in the soil. So the obvious measures, and there's many reasons for surpluses, but the obvious things you can do is try to reduce a surplus above crop requirement. That's a seasonal thing. Growth rates at the moment are lower than they were in May and falling. So the application of nitrogen to the soil now is nuts. It doesn't make sense. The soil
this time of year
releases nitrogen anyway. And that nitrogen that's been released naturally from the soil is sufficient to support growth rates that are coming in the next few months. But the second thing that is needed for nitrate leaching to occur is water moving down through the soil. And in the summer months, if evapotranspiration rates are greater than rainfall rates, we don't have water moving down through the soil. So at that time, a surplus of nitrogen in the soil is not a problem because it's not been moved. Now, if it's still there when growth rates drop and rainfall comes, it could be a problem in the coming weeks.
On the ACP program currently, you have farmers who have different sort of soil types within the farm. So they'll have different mitigation actions and different mitigation measures within the one farm area. Are the farmers good to put in these mitigation actions? And then if they are, how do you follow up to make sure that they remain that way?
By and large, farmers are good to put in mitigation actions. I suppose there is a change in the agricultural catchments program in this phase. We get funded on a 4-year cycle, and we're currently coming to the end of our first year in our 5th phase. So we've been going for 16 years, monitoring water by and large. And up until this phase, we were monitoring the measures that farmers were asked to do under the Nitrates Action Program and no more than that. People might find it difficult to appreciate that the object of the ACP wasn't to improve water quality within the catchments. Our objective was to assess the measures that farmers were implementing to see were they impactful or were they an expense and an inconvenience and not achieving what was being required. And to do that, we asked the farmers to do what they were meant to do and no more than that. After 15 years of monitoring water, by and large, in the 6 catchments, the quality hadn't changed. It was pretty much the same as it was 15 years ago. From a nitrate point of view, there was a trend in 2018 and 19, which was reflected nationally by the EPA monitoring after the drought in 18. Nitrate levels had increased, but since then they have dropped back down to what we've been seeing on average. If anything, phosphorus levels are probably increasing very slightly, and that's reflective of more intensive rainfall patterns that we're getting. The intense rainfall amounts haven't increased, but the amount of very heavy rainfall events has changed over the 15 years, and the vast bulk, over 80% of the phosphorus that leaves in our rivers and streams happens in floods that occur after heavy rainfall events.
Eddie, are you seeing that in the data? Because I know you look at you have weather stations as well, and you have obviously the monitoring. Like I'd often go out to farms and I'd be talking exactly like that about the weather, the change in weather patterns, and people say, "Oh, geez, sure, we had weather like that 40 years ago," but you're actually seeing a change in the last 15 years.
We are, yeah. Unfortunately, I'd say unfortunately, we are seeing a change, and really, what that means is, from an agricultural setting point of view, to even stand still with water quality, people have to do more.
Yeah, almost defensive systems. Actually, just something dawned on me there now. We're biased to nitrogen, talking about nitrogen because we're down in the south and southeast. That's where we're from. Hypothetical question for you: if there was no nitrate issue in the country tomorrow, would we still have a water quality problem?
Yeah, absolutely. But averages hide an awful lot, and we talk about the Water Framework Directive is driving everything, and requirements or objectives under the Water Framework Directive are we're not moving in the right direction towards achieving those. Now, we haven't fallen off a cliff face, despite what you might hear in the media and hear from some lobby groups. Water quality hasn't suddenly deteriorated. Like nitrate levels today are significantly lower. The load of nitrogen entering the estuaries over the last 10 years are significantly lower than they were 30 years ago. But they haven't improved in the last 10 years. They haven't gotten significantly worse, and in some places they're getting better, but averages can hide an awful lot. And some rivers, and again back to phosphorus and river ecology, are seeing significant improvements. Even good rivers that are starting off in a good place are seeing improvements, but other rivers are getting worse. You put the two of them together and there's no change nationally, but that's missing the problem. We need to be targeted. We need to look at our own river catchment, and I'd say even more specifically, we need to look at our own tributary of that river. And even more, then you can break that down into a sub-catchment area of that, because we have different soil types within a field, and we need to do different things with different soil types at different times of year or in different soil conditions that have resulted because of the weather.
Eddie, I suppose we've been talking a lot about problems, and I'm glad you're starting. You've mentioned that we can see some improvements, and then also I fully agree with you. Bring it back right down to field level, local level, my stream, my problem, my area. I suppose just to finish up with, what's your outlook over the next 10, 20 years? Like, are we going in the right direction? If you could fast forward 20 years' time, where do you see us?
There is no doubt we're going in the right direction. We're in a far better place than we were when I started in the Agricultural Catchments Program. The interest in water quality nationally now is way ahead of what it was. Like, we weren't doing podcasts on water quality 10 years ago, not to mention 15 years ago. People that are acting the mick and not being compliant are going to be caught out, and people that are intensive at farming now are more interested in water quality probably than extensive, and they're getting fed up with malpractice because it's having an impact on their livelihoods. Farmers are asking me about what can I do to improve water quality. Wastewater treatment facilities were under the spotlight last week with a report under the EPA, but there is big investment being put in there. Now our population is growing, and there is it a catch up, and is the level of investment meeting the population size? Certainly things are moving in the right direction. The number of major towns with significant populations that have no wastewater treatment facility is dropping the whole time, and will continue to drop. I believe there's a lot of work to be done with wastewater treatment facilities from one-off housing, and also from smaller town areas where there is treatment but not sufficient, and there's a long way to go there. But we need to be working together.
And it's important to keep it in the spotlight as well, isn't it?
Yeah, but it has never been more in the spotlight, and there never has been more resources put in it, and there never has been more of an appetite from communities to do something about it. And catchment science, the Agricultural Catchments Program, is a catchment science project, and people naturally get an understanding of the biophysical aspects of catchment science. The amount of water leaving, the nutrient that's in it, the biology that's in the river, that's all logical, and we get it. The far bigger nut to crack is the social side, the people's attitudes, introduce and practice change, why someone would do something beneficial and why their neighbour mightn't, why councils might be more reluctant to enforce measures and than in one county than another. The whole social side is a key part of catchment science. And in the last 5 years, I have seen a very big change to that aspect of catchment science. And it's because of that that I believe we're in a far better place now than we were 15 years ago. And in any event, we're in a far better place than most of our European counterparts.
Eddie, I think that's a great place to leave it. And that there is a bit of light at the end of the tunnel, but I think taking what you're saying is that we're doing the right thing, we're going the right direction, but we have to keep that going and keep that momentum going, I suppose, to reach the goals that we're looking to reach. So with that, I think, Eddie, always great to have you show, always a pleasure, really enjoyed the chat, and we'll certainly have to have you back again if you'll come. Thanks a million.
All right, take care. Bye-bye.
So there you have it. Tune in next time to hear more interesting chats and discussion.
Myself and Deirdre will be back in 2 weeks' time, but do give us a review on Apple and Spotify or wherever you get your podcasts. Thanks for listening to the Environment Edge podcast.